Okay, so again, we have our stopper is going to go in a circle, vertical circle. We want to know what's the minimum velocity to keep it in that circle so it doesn't fall. Okay, so just like always, our first step is going to be to do what? Draw the free body, right? So we're going to draw the free body. We're doing it at the top of the loop. So let's do our free body at the top of the loop. So what are the forces acting on the stopper?
Gravity.
Okay, gravity. What direction is gravity pulling? Down. Any other forces? Centripetal. So remember, centripetal describes some other force. It's kind of like an adjective. So what's the force that keeps it in a circle? Tension. The string, right? If I cut that string, what happens to the stopper? It goes flying, right? So you need to have the string there. This tension in the string is what keeps it in a circle. All right? Anything else? Is there a centrifugal force pulling it away? No. So you just have gravity, you have the tension, those two things. All right, step number 2, set up your equations. Notice we only have one dimension to worry about. That's the vertical. Okay, we only have two forces, so I have tension going down. I'm going to say this is negative because it's going down. I have gravity going down. I'm going to say that's negative also. Okay, what should that equal? Okay, let's just write it like this, MA, right? Forces, when you sum them up, equals MA. And it's a centripetal A because it's going in a circle. Good. One thing you do have to take care of here is notice, remember, acceleration is always towards the center, which means at this point it's towards the center, which is down. So the way I'm going to take care of this downward acceleration in my equation is just make sure that this is negative. Now notice, since they're all negative, how else could I have written this? Positive, positive, positive. Yeah. The key is that they're all in the same direction, so they should all have the same signs. So again, since they're all down, 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 we're going to give them all the same sign. Okay, so we are looking for the minimum velocity. So again, let's go back to this concept of the tension. So let me just show you this. So let's say I were to spin it faster. The faster I spin it, what should happen to the tension? Should increase, right? Tension's increasing. Well, let's do the opposite. The slower I go, what should happen to the tension? Should decrease, right? So it's getting less and less until what? It barely makes it around. So what would be the tension when it barely makes it around? 0. Exactly. So it's going to get less and less and less. Okay, maybe it's 2 newtons, 1 newton, half a newton, 0.1 newtons, smaller, 0.00, 300 billion zeros, and a 1. Right? Let's just round it to 0. So let's write it like that. At the minimum, those of you probably in like calculus or pre-cal, have you guys talked about limits yet? It's kind of like the limit as it approaches 0, right? And so it's going to be 0. At the minimum, tension is 0. So it's barely making it around. There's going to be no tension in the string at all. Okay, so notice what happens to our equation then. Fg equals MAC. And let's just break these down. What's the equation for F? For weight? Mg. What's the equation for velocity for AC? V squared over R. Okay. Notice what happens to the masses again. They do cancel. So this is good if you're a roller coaster engineer. You don't need to worry about if a 200-pound person gets in your car or if a 50-pound person gets in there. Everyone's going to make it. No one's going to die. V squared equals GR, or V equals square root of GR. Okay, and in fact, the only thing they have to worry about, right, is, well, the radius. What the radius is, they can figure out what's the minimum velocity to make the loop-to-loop without people falling out. Okay, for this problem, I did give you some numbers. So little g is little g, and r was 60, or convert, don't forget to convert it, so 0.6. About 2 point something. 2.42. Okay, so again, that's the minimum. That's our V minimum. If we go faster, we're good, right? If we go slower, then it falls. So this is the minimum. And the faster you go, what's going to change as you go faster? The tension is going to change. The faster you go, the greater the tension will be. All right? So I'm just going to ask 2 more things with this question. We're going to expand it, so we can call this A. Let's call this B. So let's say if the velocity is, let's say 5, so we're good, right? We're going to make it around the loop. What is the tension at the top? And then letter C, what is the tension at the bottom? Okay, so again, the question is, we're spinning our stopper. We're going to go fast enough so it's not spinning, so it's not falling. We want to know what's the tension up here at the top. Oops. Tension at the top, and then what's the tension down at the bottom. Okay, so B should be pretty easy to do because we've kind of already done it for the most part. So I'll just do B right here to the side. Because we've already set up our free body at the top. We've already set up our equation at the top, right? This was our equation at the top. But what's the difference this time? Yeah, last time we said the tension was 0. This time we said it's not 0. We want to know what it is. So last time we knew the tension, we found the velocity. This time we know the velocity, and we're going to find the tension. So everything else will be the same. So I'm just going to rewrite this equation. So T plus Fg equals MAC. And I just canceled out the negatives, right? Negative, 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 positive, positive, positive. So tension should then equal MAC minus the weight. Okay, and then AC is V squared over R, and Fg is the weight, mg. Can I cancel masses again? No, not this time. Okay, so be careful. You can't always cancel masses. Why can we not cancel it? It's not in all the terms. It's only in 2 of them. It has to be in all the terms in order to cancel it. Okay, so go ahead and solve it then. Mass was 10 grams. You do have to convert that, right? So that's 0.01 kilograms. What did I say it was? 5? 0.6 minus 0.01 times 9.8. You're probably not going to get a big number because the mass was so small. It's only 10 grams, right? It's probably a half or something. Point what?
Oh, wait, just.
Someone got an answer for me?
0.3.
319?
Yeah.
Is that being confirmed?
Yes.
All right, so let's do C. What's the difference between B and C? Okay, the location is different. So B was at the top, C is at the bottom. So what's going to change here? What's going to be different? Is our free body going to look exactly the same? No. Okay? So what's going to be different is, well, is there still gravity?
Yeah.
So that's not different. There is still a tension, but what's different about the tension? Tension's going up this time. So last time you had both tension and gravity going down. This time you have tension going up and gravity going down. In what direction is the acceleration down here at the bottom? It's also up. It's always towards the center. So at this point, at this location, it'd be going up. So when you set up your equation, you're going to have positive tension this time because it's moving up. Gravity is going to be negative again because it's going down. And then our MAC, our AC is going up, so we're going to just keep it positive. Okay? So that's it. That's the only change. Only difference is the tension and the gravity are in opposite directions this time. So notice what we're left with, MAC minus plus FG. Okay, MB squared over R. So if you look at the final two equations from the two, this one was MB squared minus the weight, and this one was MB squared plus the weight. Hopefully that makes some sense to you, at least conceptually. Is you're at the top, is you're at the bottom, gravity is kind of stretching out, so the tension should be greater down here at the bottom. And when you're at the top, it's kind of pulling down on it, so it's relieving some of the tension. So that's why you're subtracting when you're at the top, and at the bottom you're adding. So you should get a greater tension. And notice when you're in a roller coaster, how do you feel at the bottom of that loop? You feel heavier at the bottom, right? So it's increasing, that force is increasing at the bottom. All right, plug in the numbers, and you should get something larger than 319. Not a lot larger, but larger number. Point what? Okay, 0.515. That's good.